pleasant morning, evening, and afternoon, everyone. My name is Ashana Lexi Onato from the House of Joseph 11 Esther. Today we're going to talk about normal distribution involving z-table. So what is normal distribution? A normal distribution, also called as the Gaussian distribution, is a continuous symmetric bell-shaped distribution of variable. So now let's move on to the z-table or the z-value. What is a z-table? A z-table is the sign distance between a selected value designated and the mean divided by the standard deviation. It is also called as the z-score, the z-statistics, and the standard normal deviates, or the standard normal value. And the formula is z is equals to value minus mean over standard deviation.
The z-table, the standard normal table, is used in statistics to find the probability of a given z-score. The number of the standard deviation of value is from the mean in standard normal distribution. Means equals 0, standard deviation equals 1. It helps determine the cumulative probability up to a specific z-score, which is useful for hypothesis testing, confidence intervals, and probability calculation.
Now, let us proceed with the key regions in normal distribution. So firstly, I have an example of a normal distribution here in our whiteboard. So as for the mean, here's the mean. So the mean is the center of distribution representing the average value of our normal distribution. And we also have what we call the standard deviation. So it defines the measure of the spread of the data. And also, we also have what we call the empirical rule in terms of the normal distribution. So basically, in empirical rule, it will be divided into two parts. So our center is the mean and divided to two parts. And those two parts would be also divided into three parts. So here will be divided into three regions and as well as for the other side. And firstly, in these regions, we'll have a 68% and this data falls within one standard deviation. And for this part, 1, 2, 3, 4, it is equivalent to 95% of the data which falls within 2 standard deviation. And as for this, all of these regions, it will be all equal to 99.7% of the data that falls within the standard deviation.
When measuring the heights of all students at the local university, it was found that was normally distributed with a mean height of 5.5 feet and a standard deviation of 0.5 feet. What proportion of students are between 5.8 feet and 6.3 feet tall? Let's first write down the given. We have the mean of 5.5 feet and the standard deviation of 0.5 feet. And we are looking for the proportion of individuals between 8.1 feet and 6.3 feet. This is our highlighted area between 5.81 feet and 6.3 feet. To determine this area, we need to use the standardization formula, which is z is equals to x minus mean over the standard deviation. Let's put the 5.81 on the formula and it will give us the z-score of 0.62 and the 6.3 gives us 1.6. According to the standard normal table, the z-score 0.62 is equals to 0.7324 and 1.6 gives us 0.9452. To find the proportion of values between 0.62 and 1.6, we must subtract the smaller one to the bigger one and it will give us 0.2128. As a result, the proportion of students between 5.81 feet and 6.3 feet tall is 0.2128.
In conclusion, the normal distribution is a fundamental concept in statistics. It is widely used in analyzing real-world data, and its bell-shaped curve allows us to understand the probability of occurrences within a data set. And with key properties such as the symmetry, the empirical rule, and the relationship between the mean, median, and mode, the normal distribution serves as the basis for many statistical methods, including hypothesis testing and confidence intervals. And by understanding this distribution, we can make informed decisions, interpret data effectively, and apply statistical reasoning in various fields such as science, economics, and engineering. And that is all for our lesson today about normal distribution, and we hope that you've learned something today, and thank you for listening.